Welcome back to the lecture series in bioenergy. So, in the last class, we winded up with pyrolysis and we talked about some of the very interesting routes by which pyrolysis product could be used to store electrical energy, making nitrogen doped graphenes. So, in the last class, we talked about the next process where we will be talking about gasification. As the name indicates, what really gasification is? Gasification is a process by virtue of which a biomass is converted into gaseous, inflammable gaseous products. You can store, just like all of you have seen gas cylinders. Many of you who are from rural background have must about heard about gobar gas plant, or where cow dung is being used to generate gas by fermenting it in a reactor. Or you must have heard about methane gas to be used for inflammable things. And another thing which all of you have heard is natural gas is being used for cooking. So, exactly the same thing, the biomass is getting converted into gas. Now, as we do in every class, we kind of philosophize the aspect before we get into the nitty-gritty details of how this whole thing happens. So, in nature, if we look around nature, through billions of years of evolution, through geological eras, the biomass under intense pressure, temperature, lack of oxygen inside the earth crust has converted into different form of gas. And there are gas wells from where, either onshore or offshore, there you drill and you take out the gas for regular consumption. This is how nature has produced natural gases, and they have certain calorific value, and we will talk about it. Now, what we are trying to talk today is this process of gasification which has taken place over billions of years. Now, we wanted to emulate that process, or we wanted to mimic that process in a laboratory conditions, and so that we can further scale it up to make gas refineries or gas plants where we will no more depend on natural gases, or the natural gas will be supplemented by synthetically produced gas. And it has been observed, you might be wondering why we really wanted to do this, because there are several routes. Say for example, you take a solid biomass, okay, you can do a combustion, it will generate heat, and which is a good form of energy. But it has been observed, as we will walk through this lecture or a couple of lectures, you will observe that the calorific value of transforming solid through combustion to hot gas is lesser than the calorific value which is obtained when a proper gasification process is done. And we'll come, as we will walk through, we will realize that combustion process is directly a single step process, where you have biomass, you burn it, and it generates carbon dioxide and hot air and everything. Whereas, when we talk about gasification process, it is a multi-step process. Definitely there are two discrete steps which are involved. So, the way we will be covering this topic will be, we will be talking about this under 5 different headings. And here I wish to highlight one thing. There was a question in the forum requesting for the notes. So, what I did, instead of really photocopying the whatever little bit notes I have here and there, I am writing down all the notes here, so that you do not have to refer to anything else. And another question which I wish to answer through this forum is, many people are asking for different books. So, to be honest to you, there is no one book really one can refer to, because the way the whole field has evolved is, there are several people with expertise. Somebody is expertise in gasification, somebody is in expertise in engines, somebody in bio oils, somebody in combustion, some other people who are on other economics aspect of it. So, every book is written with certain degree of biasness or the expertise of the writer. So, what I have tried to do is that I read through several literature which are there, up to date research references, and I am bringing the gist for you so that you do not really need to go through a book for the basics. But if you learn this basic, then you can open any book and really can figure out what the author wants to express, what the author wants to communicate. Okay. So, there is no single book as per se, or I am not doing any specific notes, whatever I am writing here. So, I am just pulling out the very gist or the core of the subject, which will inspire you people to think beyond, and so that when you pick up any book or any research review, you exactly know what we are talking about. So, that is why what we did in the course, if you realize, we have divided it into different kind of conversion processes, and we are proceeding that accordingly. Okay. So, now coming back to the gasification what we talk about. So, this is what we will be dealing today. Okay. Gasification. So, in gasification there will be 5 different subheadings under which we will be dealing with gasification. So, first we will talk about we will introduce ourselves to what is meant by gasification, the whole process. Then we will talk about the basic chemistry. It is very essential that we understand the chemistry first. Without understanding the chemistry, nothing will make sense, that why it is different from combustion and other processes or pyrolysis. Then comes feedstock treatment. This will take you back to the earlier lectures where we talk about what kind of treatments, what have to be done, what are the properties of the feedstock. So, in terms of the feedstock treatment, we will be talking about before you put something in a gasifier or the whole assembly in which you are converting the biomass to gas, you need to do some form of a pre-processing of that biomass or the feedstock. Here what we meant by is basically the biomass. So, it is a biomass pre-treatment or biomass treatment, whichever we call it. Then we will be talking about the biomass properties. We have partly covered it, and here we will be covering it in the context of gasification. So, here it will take us back to those basic properties. If you remember carbon cellulose ratio, then we will talk about ash content, we will talk about the mineral content, because those will help us to realize what kind of feedstock or biomass is more suitable to produce high calorific value gas as compared to low calorific value products. Okay. So, that will be our biomass properties what we will be dealing with. Next, we will talk about the gasification types, what are the different methods by which gasification is being done. Under, of course, gasification type, under the basic aspects of the basic chemistry will be the same, but different designs of gasifiers and everything what we will talk about. And then, of course, in conclusion, after these 5 aspects, we will do a summary of the whole thing what we have covered here. Okay. So, this is the blueprint or the part of the notes what we will be following today. So, now talking about the introduction, what is really, so this is what is gasification by definition. So, gasification by definition, if we talk about gasification, okay. So, this is a process of conversion of biomass, into a combustible gas mixture. We will talk about what is that gas mixture consist of. Okay. Combustible gas mixture. This is the basic process, and the process which is involved in it, how we do so. So, the process which is followed is by a partial oxidation of biomass at very high temperature, which is around 800 to 900 degrees centigrade, okay, approximately 800 to 900 degrees centigrade, and in a gasification medium. And what is the gasification medium? We will come to this now. In a gasification medium, and gasification medium consists of either it could be air, it could be oxygen, it could be steam, and there are a few more which we will talk about it later. Okay. Now, if we talk about what is the basic difference with combustion, okay, difference with combustion. So, we will just do a one step comparison. So, if we talk about a combustion as such, so combustion is a process which is substantially, or the oxidation process where you are burning biomass. Oxidation process is substantially completed, in one step. So, remember this thing, it is completed in a single step process. So, let me highlight this part, it is a single step. Whereas, if we talk about gasification process, gasification converts the intrinsic chemical energy of the carbon, intrinsic chemical energy of the carbon in the biomass. If you remember, this is what I have highlighted earlier in the biomass, into a combustible gas in two stages, into a combustible gas in two stages. Okay. So, this is the basic difference. So, if we have to highlight part, this is the basic difference. This is where comes the basic difference. So, what are those two steps? Our next goal will be to understand what are those two fundamental steps which differentiates basic combustion from the gasification process. So, let us talk about the two basic steps. Two basic steps of combustion. Okay. So, the step 1 what we will be talking about is we will have a, say for example, step 1 we will have a partial oxidation step. This is step 1. So, let us do it in two tables. So, this is our stage 1 and this is our stage 2. Okay. So, in the partial oxidation, the first step is where carbon is getting partially oxidized, oxygen, carbon with lesser amount of oxygen. The arrow shows that it can move in both directions depending on the conditions. Okay. So, most of the time in the absence, in the lack of oxygen, what you get is carbon monoxide. And if you look at the heat of the reaction, DH stand for heat of a reaction. Rx stand for reaction. Either it could be positive if it is an endothermic process where you are absorbing heat, okay, and it will be negative. It is an exothermic process where you are generating heat. So, if you see the heat of reaction, that is around minus 268 megajoule per kilogram mole. Okay. Now, if the same carbon goes through a complete oxidation, so for example, it goes through a complete oxidation, okay, let us see plus O2 making it CO2, and if you compare the heat of the reaction or the DH value, that will be around just almost 406 megajoule plus kilogram mole, whereas and the third reaction in that area where we talked about stage 1, where you have water gas mixture which is involved in it, where you have, let me just continue in the next page. Okay. So, the water gas reaction which is basically in the presence of steam, water gas reaction where you have C plus H2O making CO plus H2, and if you see the heat of reaction, this is very critical, plus joule plus kilogram mole. So, if you compare the three reactions in the presence of water gas reaction, the reaction becomes endothermic as compared to, so which you can see here, this reaction is become completely endothermic. It is absorbing the heat energy, whereas these two reactions are exothermic, and among all these the biggest exothermic reaction is this one, which is minus 406 megajoule per kilogram mole. Okay. So, now if you look at it, if you compare these two values of 268 and 406, it will be around kind of around 65% of it. So, if you compare, so the conclusion from the stage 1 what you are drawing is maximum energy or the greatest energy released is derived from complete combustion of carbon, is derived from complete combustion of carbon, and the values you can compare. In the case of incomplete combustion, you have minus 268, and in the case of complete it is 406. Okay. I am just not putting the units here, but just for your comparison. You can see the comparison and you can figure it out what are the advantages, which is approximately 65%. Now, this is stage 1, where you see what are the products you are getting. You are getting carbon monoxide, carbon dioxide and hydrogen, as well as there are lot of high temperature steam and everything present there. So, you have 4 different kind of mixture which is present there. But then what happened in stage 2? Now, we will come to the stage 2 of gasification. So, let us go back where we were doing, okay, now we are in the stage 2. In the stage 2, what happens? This water gas mixture shifts reaction. Okay, what does that mean? Water gas mixture shift reaction. Okay. So, that essentially means you have CO plus water, this becomes either CO2 plus H2, and heat of reaction for this is minus 42 gigajoule plus kilogram mole. Whereas, in another reaction what you get is the formation of methane, where you are having CO plus 3H2. You are seeing a lot of hydrogen which is getting generated. It makes CH4, okay, plus H2O. Okay. So, and the reaction what you are getting here is minus 88 joule per kilogram mole. So, what you are producing here is methane in the second step, and every time you are observing that I am putting an arrow like this, like, which basically shows that the reaction are in equilibrium, shows the reaction are in equilibrium and can proceed in either direction. So, this is your control point for a reactor, can proceed in either direction depending on temperature, pressure and concentration of reacting species. Okay. And essentially the product gas what you get out of this whole process, what we call as the product gas, is a mixture of. So, this is, you remember I told you that it is a mixture, product gas from gasification is a mixture of CO plus CO2 plus methane plus hydrogen plus steam or water vapor. This is a complex mixture what you obtain out of this whole process, and unlike combustion, now if I compare it to an unlike combustion which produces only hot gas. So, if I see combustion, if you compare it with combustion whose end product is basically hot gas, if you compare with combustion you will see, on the contrary, in gasification what you are getting is a complete mix of these different things in the gasifier. So, the amount of product is totally different. And what are the advantages of such things? If you look at the advantages of this gasification process, the gas produced can be standardized. Okay. So, I will close it here. Thank you.